Over the past 2 years, I've been turning my whole front garden into a secret underground garage. I've got access to this via the house and the workshop through epic underground tunnels and a mind-blowing vault door. But I built this room to garage my DeLorean, which means I've got to design, build a mechanism to bring the car from the top surface down into the room. And once it's in the room, I want to turn it round as well. If you thought digging and building this thing was hard, this is on a whole nother level. How am I going to do this? How am I going to get my car from the garage up to the surface? I have never built anything like this before. Okay, so what you're looking at here is a scale model of the end of the room where the car lift is going to go. Now, the distance between the surface level and the floor level is 3.4 metres, which is quite a lot. Now, the simplest way to do it is this. 4 telescopic posts in each corner with hydraulics in. The hydraulics extend, taking the car to the surface. Simple, it's very nice, but there are safety issues, there are height issues, and there's added complications that I want to be able to turn the car once it gets in the room, and I also want to use this as a bit of a work ramp to be able to work on the car. Now, this video is sponsored by Onshape, which is a cloud-based CAD drawing program, so I've drawn it in there, and I'll explain how I'm doing it. This is a section of the room that the car lift will be placed in, with the 2 walls at either end and the face of the opening to the surface. 4 posts will be placed in each corner with hydraulic rams inside. Each of these 4 posts will have an outer sleeve placed over them. These will all be connected at the top via a frame. This will also support the top surface. The hydraulics will elevate these legs and frame and the upper surface, but it doesn't have to go the full distance. At the base of the room there will be a turntable mechanism. Within this turntable there will be a separate plate. This is what the car sits on. Within my 4 outer posts there will be a secondary inner lift. This will pick up and raise the platform that the car sits on, lifting it to the necessary height, so when the outer legs and frame raise up, they don't need to go the full height to bring the car to the surface. This inner lift can also double as an inspection ramp to work on the car for maintenance purposes. When the inner lift then places the car platform back onto the turntable, it can continue down just under floor level, meaning the turntable can spin continuously, being flush and level with the garage floor. Okay, there's the challenge, but where does Colin start? Well, I'm thinking if I build one of the legs, have a look at it, see if I'm happy with it in the real world, and then we can take it from there. Now, the legs themselves are essentially going to be 2 bits of box section sliding over each other, but we don't want metal jingling around. We want to put some sort of sliding pads in. But there is an issue with box section. It's not always square, is it? I think we need to do an experiment. So, over to the guys at Newark Steel to bring me 2 flavours of box section to try out. So, with it unloaded and placed in the barn, is this going to work, Colin? Okay, I was right to be concerned, but it's not that bad. At the end here, it's pretty straight, it's pretty square, but a little bit further down, it does tuck in a little bit. Now, rather than scrap this whole idea, I've been looking at how the telehandler does it, and I think we could borrow something from there, so I'm going to chop a little bit off the end here and have a little experiment. Just cut a bit off the end, Colin. How hard can that be? Well, quite difficult when it doesn't fit in your bandsaw. You can't physically move it yourself or flip it over. It all gets a bit tricky. So, my initial idea was to get these long nylon pads, have them fixed up the entire inner leg. But of course, when you go to fit them, put the bottom one in. When you go to fit the top one in, you can't get it in because the tolerances are too tight. Now, we need a bit of adjustment as well, so if we can't even get them in to start with, this is not a great start. Now, if you look at the telehandler, basically on the end of each boom section, there is just pads which sit at the ends, so we don't need the whole length, and that is under way more pressure than this is going to be, because obviously that works horizontal. So we're going to do this. Okay, this is clearly a better idea. Now, essentially, I've welded some plates on the bottom of the leg, and then the pads slide up between them, and then obviously to settle the distances and get the tolerances nice, you add some little shims above it to get everything where you want it. Now, the pads are held into place by these 2 bolts, and there's like a nut and a washer countersunk into the pad. But I've had an extra idea. Why don't we move these back a little bit, have another 2 holes here, thread them, then have some little grub screws or some other bolts which go down and just push on the pad slightly. So if there's a little bit of play in it, we can just tighten them up and take it out. Because all this is just to stop the foot rattling, so when it goes up, it's nice and smooth. Now then, what I'm thinking we'll do is I'm going to make a complete leg up, see if it works, put a hydraulic ram in it, have a look at it. If I like it, we'll make another 3.
Now, rather than struggling cutting these myself, of course Newark Steel, the sponsor of this metal, they offer a cutting service. So I've got them to cut 4 legs, which are just a little bit longer than what I need them to be, so I can trim them down later. Now I've got them on the fabrication table, I've got all my plates cut up, I've got them marked up. Now, I've actually gone a little bit thicker this time. I've gone for 10... Oh, God, I've got hiccups. I've gone for 10 mil rather than 6. Oh, who the hell's that? Threading them up. Oh, I made this little jig thing, look. So you put it on the table, you clamp it down, and you can put all the holes in exactly the right place so they all line up nicely. Stick them on the pillar drill. I've used this wood bit, which is the whole thing which you can't sink in. Oh, God, I don't know if I can use this voice ever. I clamped them on. Yep, the countersink thing, you saw that. Clamping them on, get them all in a nice place, weld them on, lovely jubbly. To turn it round, I have to put a massive clamp on it because I can't pick it up because the thing's so blooming heavy. I then got 2 right angle clamps clamped together as like a bit of a height tester to see if the plates were flicking up. Clamped them down where necessary, welded them up, and your booty, it looks brilliant.
Yeah, and these adjusters, they work. Tighten them up, you can see the shim just move ever so fractionally, so if there's any slight play, we can get rid of it using that. Fantastic. Right, the rest of the leg is complete.
The top pads on 2 sides bolt straight onto the box section with adjustment shims slid in from the back. The other 2 pads are fixed to a protruding plate and are slid in from above. Now, we need a hydraulic cylinder with a 2.4 metre stroke. You can't buy them off the shelf, so temporarily I've connected 2 shorter hydraulic rams together, back to back. The inlet and outlet ports have been connected together, connected to 2 hydraulic hoses, which will come down and drop out the bottom of the leg. As the hydraulic ram doesn't sit at the base of the leg, I've made this little extension table for it to mount on. This slides down the box section to hold the ram in the right place. And at the top end, I've fitted a cover plate, but to spread out the forces, as well as mounting a pin, I've also made this little cradle. This bolts on the underside of the top cover, and then the hydraulic ram's pin end sits nestling into it, meaning the force is spread up through this and not onto the pin itself.
Okay, now in Onshape, in the virtual world, this slides up and down absolutely perfectly. But is it going to do that in the real world? So, while I'm putting all this together, Onshape. What's it all about? Onshape, the sponsor of this video, is a cloud-based design studio. Now, I've been using it to design my car lift, but I have barely even scratched the surface of its capabilities. And it's not just useful for me as an individual working on something like this. If you've got a massive team of people working on something super complex, that is when it really shines.
With Onshape, everything's in the cloud. No files, no installs, so you can spend your time designing instead of managing CAD data. And because it's cloud-based, multiple people can log on from a range of devices and work on the same project.
And with real-time data management, this prevents version conflicts and duplicated effort, lowering the risk of manufacturing errors and rework. So if the hydraulics manufacturer made an adjustment to my lift, I would see it straight away. He's got the ports on the wrong side. And equally, it's a great way to share designs and input for feedback purposes.
And with branching and merging capabilities, people can experiment freely without disruption of production designs, enabling faster innovations with less risk. So, somebody can look at a feature and think, actually, I have another route this could take, or a better idea, draw it up, offer to merge it with the current design, or stick with the original. But this allows experimentation without the fear of disruption. And because the software is not on your device, you don't have to deal with broken files, version chaos, teams can just get on with designing, and that's where you really save time and money. And with their newly released model-based definition feature, where the 3D model becomes the single source of truth, you don't just have dimensions, you have tolerances, weld informations, all live on the model, not on a separate drawing. And a feature I really love is the augmented reality view, allowing me to project my design onto a setting to see what it looks like in real life.
So if you're a company looking for a new CAD solution, or you're a professional user, Furze has got the deal for you. You can get Onshape Pro for 6 months for free, the link in the description. Go for it. Right, Colin, back to the project.
Now, with all these pipes and fittings all over it, is this cylinder actually going to fit in the box section now?
Oh, just fits in.
Oh, thank goodness. So, with the cylinder in, I picked up the outer leg, shimmied across the workshop, and then using the fabrication table, I pushed the inner leg into the outer leg, slid the pin in, and then stood it up. Oh boy, is it tall.
Look at it! It's a monster. I don't know why I'm shocked at this. I knew how tall it was going to be, but it's kind of weird because when you're in the underground garage, you don't look at it and think, oh,
that's that tall because it's just a big room, but as a pole it looks taller. Anyway, shims, they work an absolutely treat. The adjustment on them took all the play out of it, beautiful. But does it go up and down nicely? Let's put a hydraulic pump on it and have a test. Okay, pump's connected. I've also added an extra oil reservoir. And off we go! I remember now, this pump's really slow. Yes it is, but lucky for you guys, I can turn 10 minutes into 5 seconds. Okay, that seems to work quite nicely. Obviously it's ferociously slow at the moment. I give it a bit of a wiggle halfway up to see if there was any play halfway up the leg, and no, the shim's doing their work. Fantastic. So I think let's put it under a bit of strain now and see how it performs. So I've got 2 ton bags of sand from a company that when they answer the phone, it sounds like they're questioning your sexuality. So surely a ton bag of sand weighs a ton, right? No, 770 kilos. So I added a little T-bar to the top so we could hang 2 bags, giving us 1.5 tons of strain. Right, here we go. Now I placed a telehandler either side of it so if there was any snappages or anything, it couldn't pull it over. And it took the strain, we got bags a spinning, they're off the floor. Feel the power! Yes, Colin. Now once the bag's got a little bit higher, I give it a wiggle, give it a kick, it all seems good. So I sent it up a little bit higher and then I lowered it back down again. Okay, this works, but am I happy with it? Okay, so what's this leg got to do? What boxes does it have to tick? Well, it's got to be strong, of course. It is the main chassis of the car lift, and it's got the middle car sort of hanging off it, and it's got the drive and everything else on the top bearing down on it. Now, I think we've ticked that box. I don't think it's going to bend or snap or anything. That is good. Now, it's got to have a 2.4 metre stroke, so it's got to be up 2.4 metres. It does that nicely. And also there's about 1200 mil of inner leg left inside the outer leg when it's at full reach. I like that, nice and stable. How much weight does it need to lift up? Well, there's 2 parts of this car ramp. There's the inner ramp, which will pick the DeLorean up, and the DeLorean only, and the platform it sits on. Now, depending on what car you park on it, that's probably going to be about 2.5 tons max. That's not too much. But these outer legs are going to have to lift everything up. The inner car, the platform, all of the chassis, the drive above it, which alone could be about 2.5 ton. And then also, what if Colin parks another car on top of it? You might want to pick that up as well. So in total, probably going to have to lift about 10 or 12 ton. Now, split between 4 hydraulic cylinders, that is not a massive ask, but it is something we have to think about. And as well as all that, it needs to be maintainable once it's all complete and all fully built. Now, these slide blocks I've put on the bottom ones pull out really easy and swap them over. I've tested that, absolutely fantastic. The top ones, it's a little bit trickier to do, but you can do it, even with the camera in the way. Unbolt them, slide them out, put some new shims in, brilliant, I'm happy. But the only other thing we've got, of course, is the cylinder. It is stuck in the middle of that internal leg and you can't get at it very well. Now, my original thought would be able to disconnect the leg and lay it down in the room. But now, as well as that being massively complicated, I've weighed these legs and they are 460 kilos each. So even with a winch somewhere in the room, that is going to be a pretty tricky job. So I think we need to look at the internal leg setup and see if we can get access to that cylinder while it is all still constructed. Now, at the moment, there is a lot of hoses on the cylinder, but once I've got the bespoke one, it'll be single acting and it'll only have 1 inlet at the bottom. So we don't need to worry about the hoses so much, but we do still need access to it. And I've got an idea. So I swung the leg round, put it back on the fabrication table and started pulling it to bits. I thought this was a good time as well to check to see if anything had got bent, which it hadn't. Nothing to worry about, Colin. I then began to pull the inner leg out, which I found was much easier by ramming the fabrication table against it and using the weight of that to slide it out. Oh, beautiful! So with them both separated, I could take the hydraulics out and get on with my plan, which is, Colin? Ooh. Okay, so I'm going to slot the inner box section so we can basically raise the leg up, lock it off, disconnect the hydraulic cylinder and then pull it out the slot and slide it into the room. But we need to know how long that slot needs to be. So you can imagine this is our leg and this is our hydraulic cylinder. We need to know that when it is tilted back in the leg and then pulled forward to the point that it can slide out, what is the measurement between that gap there and where it crosses over here. And on our setup, that is 1.4 metres. Now, we'll go 1.6, so we've got a little bit of slack, and then we can just, and then pull it out. Yes, a slot, Colin. Now I'm going to cut this slot out with a grinder, so I've made these little fences for it to work up to. Now I would have used a plasma cutter, but my handheld plasma cutter doesn't make a very good job of 10mm, whereas by running a grinder along this, I get a nice, smooth, straight cut. After I've cut a section out, I check with my vernier calipers that the box section is not opening up. And to stop this happening at all, I've made these little plates which I'm going to weld in every 300mm, so hopefully that will keep it all intact. And that's one in, so just copy and paste. So now we've got a nice big slot straight at the box section and hopefully retaining as much strength as possible with my little gussets. Now, this has caused a few issues. The little extendo piece that the hydraulic ram sat on, you can't get that in anymore, so I've had to cut a hole in the bottom of the base plate so I can slide it up from the bottom. Also, the hydraulic rams, because it's two connected together, there's these big spigot things which stick out the side. They've got to go, so I've cleaned them up and TIG welded them together. Well, I'd love to now tell you that I put it in and it was fantastic, but unfortunately that's not how it went. All the hydraulic pipes are in the way. I tried multiple angles, multiple different methods. I just couldn't get it in. So I thought, Colin, you're going to have to shove it back down the other end. And that didn't work either. So I ended up disconnecting all the hydraulic lines, spraying oil everywhere, and reconnecting them back on when the cylinder was in the leg. So is it in now, Colin?
Okay, that's got it all together. Now I would love to try and change the ram while it is in this position, but because of all the hose issues, I'm just going to have to believe that I can do that. And then obviously once I've got the bespoke ram with the single hydraulic port, it should all be good. Now, next on the job list is when this is in the room, the whole ramp itself, the whole lift, has to be fixed to the room on some sort of guide rail runnery system to keep it all nice and true and level, stop it jingling around, and just generally it's a blooming good idea. So what I've done, I've lowered one of the spare outer legs into the garage so we can see how that's all going to work. Okay, so the leg's going to sit in the corner like this. I think the best place for a guide rail is on this back edge here. So we need to mount a column or something which comes up this wall, fixes to the wall, and that's nice and solid. Now, the thing that we have to be careful of is obviously we've got this little stick out bit, this little ledge up here. So it's kind of got to guide its way round or through that or whatever it is. And then whatever clamps onto this column has got to be able to get past that because obviously it gets a lot thinner. So I think what we might have to do is bring this leg into the room a little bit, which I don't mind doing, but what I don't want is have anything on this side or this side which pushes this leg in that way, because then the two legs will come together and then what you drive the car in between will get smaller, not very good. So, big H-plate column coming up here, we need something to grab it.
So with a short piece of column beam, I offered pads and blocks behind it, looked at how the plates would hold them all in place, but I didn't really like it. And I tried all sorts of methods. And then I thought, what about bearings? This is going to be a lot more accessible than all the slidey pads, so I could have a nice bracket with some bearings running up. Then, having to put together a rough concept version, I offered it up to the beam, and Colin's happy with this. Then added bearings that run up the inside of the column, and voila!
Okay, this is the design I've landed on. We've essentially got 4 sets of triple bearings. I've done triple bearings because obviously we want to be spreading the load. They sit in on short, stumpy 30mm shafts. We want them to be short and stumpy because we don't want any deflections or flexing in them. This, at the moment, is a bit of 10mm plate. Might actually make that a little bit thicker because obviously any massive stresses, that might start to open up. We don't want that to happen, do we? No. Now, in terms of the actual adjustment, these inner bearings are completely fixed. There's no adjustment because if the column's level and the leg's attached to it, you want that to be level. That just wants to run up proper. But of course, if there's any slack or any play, these ones here are on little slots, so you can move them down and take any of that slack out. So I think what we're going to do now is I'll give it a good old run, and I've kind of wiggled it about and it seems fantastic. But let's kind of put this on the big long beam, stick a big long bit of wood or something in here and proper swing off it, see if we can break it basically.
So, lifted the beam up, slid it on, ooh, promising, and then stuffed a bit of wood down the end and hung off it. Now, me hanging off it puts about 250 kilos of force on it, which it coped with nicely. But let's overstress it and see where the weak point is. So I attached our 700 odd kilo bag of sand on it, lifted it up, oh, that's not going to work, Colin, until it broke.
Okay, that was a pretty good test. Now, it mostly failed because it was only tack welded together, and I'll admit I forgot that. But anyway, it showed us where all the weak points are. This base plate has started to banana. That could probably do with being a bit thicker. Same with these side plates. As you can see, the mill scale has cracked. where it's starting to get a little bit stressed. Now some of this is because Colin has foolishly put a hole in here, but I've left square edges on it, not curved edges, because curved edges distribute the stresses better, and then you're less likely to get all those problems. So I'm going to order some thicker, stronger metal for that, but while I'm waiting for that, I'm going to change these slotted bearing adjusters to eccentric cams. Oh, you're going to love this. So I want to put an offset hole through the bearing shaft so I can twist it and it will put it further or closer to the column. Now normally to make this you'd put the 4-jaw chuck on, move it across and drill it. But that's a lot of finicking about. I've got loads of these to do, so I've made myself a little jig. This basically, slide that in there, it goes in the 3-jaw chuck, you clamp it up and then you can drill it just like normal. Excellent. And to make this, I 3D printed a bigger one which made that one, oh, it's like a centipede of jigs. Anyway, while I've been doing this, my stronger steel has arrived. Ha!
Hello, Mr. Furs. Some stronger metal for you. New steel. Barrett's on time.
That guy is also called Colin. So with the thicker steel making the plasma cutter scream, I put myself together a nice big meaty Mark II.
Oh, look at this, look. This is just a big lump of meaty hell yes! This is obviously a lot thicker. Now, the previous one was 10mm thick, and most things I make, to be fair, 10mm thick plate is considered pretty thick, but this is 15mm now. This is not going to break. Now, a couple of things you need to know. The plates are actually offset from the back plate. Beforehand, I had a 10mm spacer. Now I've got two 5mm spacers, and a little tip. How do you space things off? If you haven't got one of these wonderful Fireball tool spacing sets like I've got here, use drill bits. Two 5mm drill bits, put down the side there, perfectly 5mm. And of course with drill bits, you've got a whole set of 0.5mm increments. Fantastic. My little offset holes that I've drilled, I've took them home and milled a little slot in each, so I just get a little 4mm rod, poke it in, give it a twist, you can see it moving around. Oh, that is just beautiful. Right, let's put this on an RSJ, hang some stuff on it, and be happy.
So I slid it on, took the slack out the bearings, and tied my big bag of sand to it. And then picked it up and sort of had a game of wibbly wobbly back and forwards. I have no idea, but it was so much fun.
Okay, that's passed. There's no signs of stress. It's got nearly a ton hanging off it, which is way more force than it's ever going to be exposed to while it's in the room. Now, the other thing I need to do is we need to kind of make another version of this now that sits on the front here. It's going to be sort of opposite because obviously there is an inner lift, the thing that lifts the car up. Talk to me, Furs. I hope I'm explaining this okay. I'm doing my best. Okay, so on this side of the leg, we technically need the opposite to what we've done here. This is the bearing running up a column. We now need the column on the leg here for a bearing to run up against it. So, we're going to do this. This is a bit of 100x10 bright mill flat. And then it goes on to a bit of 25x50, which then bolts to another bit of 10mm, 100mm flat, which we're going to fix onto there. Now, it is all countersunk. It is all going to be fixed. There is going to be loads of bolts. Right, now I'm not going to make a little jig or test thing or anything. I'm just going to fold the leg down, get it on the workbench. We're going to put it straight on it. I'm going for it. Yeah.
Now, rather than adding separate plates for all these guides to be bolted to, well, actually, the plates that the blocks sit on should continue up the leg. Not only that, I'm going to make them thicker. Because we can't get nuts on the end of the bolts, because we can't get to them, we need more depth of thread to account for the fact that a tapped threaded a bit of mild steel is not as strong as a nut. So I've got my 15mm plate welded onto the leg. Beautiful. I then drill and tap them, and up at the top where there's more pressure, I've even added a little plug weld. Then with both plates mounted, it's time to make the big long inner lift runner rail. Now this is 2.4 meters long, and it's going to be bolted on, so if there's any problems we can unbolt it. There's a lot of marking up, there's a lot of pilot drilling, and there's a lot of drilling and threading.
Okay, that is looking beautiful, Colin. Now, of course, what is running on this? Well, it's kind of similar to the other side, really. We've got this little bad boy. We've got bearings. We've got the little wiggly jiggly orientation thing. Now, this is kind of like a small test version because I was like, let's just try this. I've got bearings in sets of 3 because if you think about this, the weight's going to be pulling on it. So the one set, it'll be a lot of pushing force, and then the top set, it will be a lot of pulling force. So I thought if we have them in groups of 3, 2 of them can be angled onto the side of the plate, which is taking all the force, and the other one can be pushing on the other side just to stop the flop. So I thought I'll just do a little short one because the actual main one will probably be twice as long as this. So I think we'll slide this over here. You go on there like so. Right, let's tighten all these up and let's see if we can get to the middle ones, because this is the issue, is this middle bearing, you can slide it in, but can you adjust it? Because it's a little bit pokey, shoved down there, very tricky to get at. Or am I going to have to do away with that and just have them in groups of 2, but have more of them?
Well, not only could you not get to the middle ones, even the outside ones were a bit tricky. Not only did I say no, but even the local wildlife said no. Rubbish.
No, too fiddly. So I had an idea. Basically, I've put a longer bolt which goes in, hits out on the bolt at the end, which holds the bearings on. You can then turn that, tighten the nut up to adjust it. Boom. I think it's good. Seems like it's working. Right, now this whole thing is going to be pulled up and down this track with another hydraulic ram.
What? This hydraulic ram, Colin? It's a bit smaller.
So, now you may have noticed I've slid it all back together again. It is now complete. I also noticed, while I was sliding it back together, that the inside of this big box section was pretty dirty. So I put a grinder on a big bit of metal, wanged it in, give it a good old clean. Now, I've also chopped it down to size, so this is now the correct height to go into the secret garage. So, stand it up, give it a lift test, and then go and put it in a room and see what I think.
So with it stood up against the wall, wedged in with a telehandler, I've added a little branchy arm thing up and let's lift some sand again. And of course it lifted it straight up with no issues. Checked the bearings to make sure everything was touching where it should be and not where it shouldn't be. I gave the arm a bit of wiggle to see if any induced flex had been introduced. No, we were perfectly fine.
That's worked. It hasn't broken. In fact, I've been looking at it thinking, Colin, maybe you're worrying too much. It's just lifted up 800 kilos of sand. I've only tack welded that on, and then I lifted the whole leg up with one strap, which goes onto a little eyelet, which is on one M12 bolt. So I don't think you need to worry about this. It's got like 50 bazillion bolts in, super thick plate, and welded up like mad. That aside, it's just lifted 800 kilos. Obviously, there's going to be 4 legs, 4 times 8, 3.2 tons. It's way more than this is ever going to have to lift because this is just for one car. So, I mean, the DeLorean's like, I don't know, 1.8, 1.5, something like that. I need to check that out, put it on screen. But anyway, that's all good. So I'm going to stop waffling. I'm going to lay it down, stick it on a trailer, take it home, drop it in the secret garage. Yeah, boom!
Subscribe.
Amelia, he said we're going tonight. So grab your coat and run away for the rest of your time. He won't say no to all the clothes that you used to wear.
Okay, it's in the room. Colin's happy. Happy with the height. Looks cool. It's got to come a little bit further forward because the column's got to go behind it, but I need to cut that and kind of get that all mounted in the room and get it all sorted. But before I do any of that, obviously we've got some hydraulics to order. I'm going to get a structural engineer to just check the design, check there's no massive flaws in it somewhere. Once he's happy, then I can start making the other 3 and get it all linked up and working. Now, there is 2 more things that need to go on this leg, one of which is a safety brake. This is like this little clampy thing. Basically, that is attached to a cable, and then if the whole thing tries to come down too fast, it pulls this on. There'll be another bar of metal coming down the wall. It will grab onto it, and it will lock onto it. And this can take 7 ton. Now, there'll be 1 on each leg, so it's more than capable of holding up the weight of the whole thing. And also, a lot of people have been worried about, because this is all hydraulics, you've got 4 hydraulic rams, what if they don't go up evenly? So essentially, each leg will be daisy chained to the next leg using a cable system. So if one leg starts to slow down or go up too fast, it pulls on the one next to it, and the one next to that, and the one next to that. So technically, it can't go out of sync. At least it works in my head anyway. That's all going to happen. Subscribe, you don't want to miss any of this project. This is testing me like nothing has ever tested me before. But I'm happy. I think this looks good. It looks strong, and it looks like it's going to work. Right, see you in the next one.